Hello class, it's Miss Coletta. I just wanted to show you another example of how to do the rectangle area method just to refresh your memory on some of the basics. So looking at this example here, we have using 5 rectangles approximate the net change, which we know just means an integral, from 0 to 10 for the following function. F of x equals 3 times the square root of x. And just to refresh our memory, we can write this as an integral because an integral is the same thing as a net change. An integral is that elongated S sign, and if you remember, at the bottom of the integral we put the number that we want to start at the top we put the number we want to end at. So here we are going from 0 to 10, and then inside the integral you can either write f of x dx, or you could write the same integral, 0 to 10, and you could put the whole function in, 3 square root of x dx. So if ever you're asked to write the integral or write the symbolic expression for the net change, that would be what you would give me. Now if you look over here, I've given you a quick sketch of the graph just so that you can see the square root function, and you'll notice that while I put the scale along the x-axis, I did not put a scale along the y-axis because I'm not as concerned about what the actual y values are, because I know now that I have a function rule, I'm going to use my calculator to find the actual y value. So I don't need to have them in my graph, I do need to have them in my calculations. So let's go ahead and get started. The very first thing I do is I look at how many rectangles I'm using over the interval. So here I notice I'm using 5 rectangles and the interval is from 0 to 10. So I have to ask myself, how wide will each rectangle be? Well, 0 to 10 is 10 units, and I'm dividing by 5 rectangles, so each rectangle will have a 2-unit width. Then what I do is I go to my graph and I kind of block off where my rectangles are going to fall. So my first rectangle will go from 0 up to 2. My second rectangle, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. And if I just check very quickly, 1, 2, 3, 4, 5 gaps will give me 5 rectangles. Now if you remember, we've decided that our rectangles should always hit the graph at the midpoint of each rectangle, which means if my rectangle is going from 0 to 2, I want to use the value 1 to make my rectangle. So what I'm going to do is, in between each set of tick marks for each rectangle, I'm going to trace up to the curve and put a dot. So here between 0 and 2, I draw my rectangle going up to where the graph hits at x equals 1. And I'll do the same thing for the rest of my graph. And I'm just going to quickly put the rectangles here so we have our sketch all set up and ready to go. Put my dot and draw my rectangle. Trace up, put my dot and draw my rectangle. And last but not least, trace up at 9, put my dot, and then draw that rectangle. So now we're ready to go ahead and actually do the calculations. So basically what we're trying to do here is estimate the area under the curve, and we've chosen to fit this curve with rectangles just because that's the new strategy we're using and because it helps kind of approximate the area under the curve. So looking here, I just want to find the area of each rectangle. So what I do is I set myself up with my integrals for my calculations. So I'm just going to write again the integral notation, 0 to 10, and I'm just going to write f of x dx equals, and now I know I'm going to have to do the base times the height for each rectangle. Now looking at this first rectangle, I know that the base is 2. Every base on this picture is 2. So instead of base, I'm just going to put a 2. And then the height, if you look at this rectangle, is going to come from x equals 1. And if you notice, we chose x equals 1 because it was the midpoint of the rectangle, and then we traced up to where this hit the curve. Now in function notation, what we would write is f of 1. And what that stands for is the function output when x equals 1. We'll worry about finding that actual value in a second, but that's how I'll calculate the area of that first rectangle. And again, remember that 2 is like our base, times our f of 1 is our height, and that's how we calculate the area. So then we'll just go through and do that for every single rectangle. And it'll change based on whatever your interval is, so just be careful with your values here. Now, looking here, my base is 2, and my height comes from 3. So I'll write a base of 2 times the height, f of 3. And I'll continue with the rest of the rectangles. The next one also has a base of 2. The height comes from 5 up here. So I'll write f of 5. The next one has a base of 2, and a height comes from x equals 7, so I write f of 7. And the last rectangle, the fifth rectangle, 2 times f of 9. Now remember, each of these little quantities is an area of one of the rectangles. So that's what we're looking at there. Now we're ready to go ahead and actually look up our values. And be careful that you're very neat with your work here so that you can really follow what you're doing. So the first thing I do is I just set myself up to kind of continue my work right underneath of where I have it. So I have the 2 times, and now I want to figure out what f of 1 is. So what I'm going to do is I'm going to go to my calculator, and I'm going to set up my table in such a way that I can look up what that f of 1 is. And I'm going to quickly show you 2 ways to look it up in your table. Okay, the first way, first of all, no matter what you do, you want to enter your function rule in your calculator. So I'm going to go to my y equals. My function rule for this example is 3 times the square root of x, and the square root is the second and then the x squared button. And then I'll put my x. And you would have parentheses here that you would have to close around that x. My calculator is slightly different than yours, so I don't have any parentheses. And then I'm going to go to my table setup. And what I'm going to do is I'm going to look back on my example to decide what my table start and my delta table should be. So when I look back at this example, I know that the very first value I want to look up is f of 1, or the y value at x equals 1. So that's where I'm going to start my table. And then I notice as I look across here that it's skipping by 2, because each rectangle is 2 units wide, so to get to the next height it would be 2 units up. So that's what I'm going to make my delta table. Okay, so back to the calculator. I'm going to do just what I said. Make the table start at 1, make it count by 2. Then I can go to my table, and that f of 1, f of 3, f of 5, f of 7, and f of 9 are all sitting right here in my table. Okay, because here, when the x value is 1, this 3 is f of 1. When the x value is 3, this 5.1962 is f of 3. So I can just copy these down every time I need them. So this first one, 2 times f of 1, I know that f of 1 is simply 3. And then I put 2 times, and in place of f of 3, I'll go to my calculator, and I'll pick out 5.1962. And just to help us out very quickly, I'm going to copy this into my screen so I don't have to keep flipping back and forth. So here we go. Here's a little picture of my calculator, and I'll get rid of it in a second. And then I'm going to copy these down. So f of 3 was 5.1962. Plus 2, and then I need f of 5. And f of 5 looks like 6.7082. oops, and then 2 times f of 7, and f of 7 is 7.9373. And I'm carrying a lot of decimals here just because it gets pretty messy otherwise. F of 9 is nice and easy. 2 times just 9. Now what's nice after this is all you have to do is multiply each of these products together. Remember, each one here is an area. Okay, so 2 times 3, 2 times 5.1962, 2 times this, on and on and on, and you add in between. Now, you can enter all of that in your calculator in one stream, but just be careful there because it's a lot of stuff to enter. So make sure that you're putting plus signs in between each product and you're multiplying in between each pair that is the product. So just be careful as you're entering. I'm going to go back to my calculator and enter it, and then I'll just pause the recording while I do that so you don't have to watch me type all those numbers. Okay, and I'm back. And I have my total here on my calculator. If you look after I've entered this whole product, I get 63.6834. And that is my final answer. What this represents, again, is the approximate area in square units underneath my graph here based on these 5 rectangles. So what I've done is I've found the area of each individual rectangle in each of the products, the base times height, and then I've added them together to get a total area of 63.6834 units. Now again, if we had a function that was, say, a velocity time situation, then our area would represent the total distance traveled, the accumulated change of that function. So if it was any other kind of area, it would just be the accumulated change based on the units in the problem. I hope this helped you kind of take a second look at this situation and get another idea of how to do it. I do just want to show you very quickly on the calculator another way to get these y values if you don't like using the table setup. And that would be if you go on your calculator and you go to your table setup. Instead of worrying about the table start or the delta table, it wouldn't matter what you have here. If you turn your table, the independent section, onto ask, this is what's called table ask if you hear teachers refer to this, and then you go to your table, what you'll have, and again your function rule has to be in there. Whoopsie, I went to my graph, sorry. What you'll have in there is a blank table. And then if you know you need f of 1, then you just put 1 and hit enter, and it spits out f of 1. If you need f of 3, you put 3 and hit enter. F of 5, put 5 and hit enter. 7 and 9, and that should give us those same 5 heights that I needed. So whichever works better for you, either set up your table to count the way that you need to find those y values, or use your table ask function, but those are 2 options for you once you've put the function rule in y equals to help you find those y values. Alright guys, I hope it helped.